Welcome students to this mathematics session for grade 10. So we remain with the topic of indices and standard form. In this lesson, we are going to learn how to solve exponential equations or simply equations involving indices, and secondly, we are going to learn how to write down a given number in standard form and vice versa. So we start with exponential equations. Well, how can we identify an exponential equation? Any exponential equation is an equation in which the unknown x is found in the power. Whenever you have your unknown which is found in the power, the equation becomes an exponential equation. For example, you can have 2 to the power of x equal to 16. You see the unknown is x. And where is it found? It is found in the power. Another example of an exponential equation might be 3 to the power of 2x plus 1 equal to 243. Still, the unknown x is found in the power. You see these type of equations, we call them exponential equations, right? And how do we solve exponential equations? Let us see. First example, we are told to solve the following equations. First part, we have 2 to the power of x equal to 8. Right? So by solving this exponential equation means to find the value of the unknown x which is found in the power. How are we going to attempt these type of questions? Let us see. The left hand side is in index form. With base 2. The base is 2. Index form with base 2 and the power is x. What about the right hand side? It is simply the number 8. So we need to convert the number 8 to base 2. Why we convert to base 2? Because the left hand side is in terms of base 2. Always you have to work with the same base. So the left hand side remain as it is, 2 to the power of x. How can we convert 8 to base 2? By simply dividing by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. And 2 divided by 2 is 1. So 8 is simply 2 to the power of 3. Because 8 is 2 times 2 times 2. Right? So now we have reached a situation in which on the left hand side we have base 2 and on the right hand side we have also the same base which is 2. Whenever you have same base on both sides, then you have to equate the powers. Whenever we have same base on both sides, This means, therefore, the powers are equal, meaning here we have power x, this must be equal to the power 3. This is the answer, so x is 3, right? So to recap this whole procedure, the first step is to convert the number 8 in terms of base 2, because on the left hand side we have base 2. Then whenever the two bases are equal, we have to equate the powers. Let us see the second part. Here we have 2 to the power of 2x equal to 16. Again, let us identify the base on the left hand side. The base is 2. So we have to convert 16 to base 2 as well. So we take 16, we divide by 2. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And 2 divided by 2 is 1. So we write 2 to the power of 2x equals, and what is 16? 16 is simply 2 times 2 times 2 times 2, which is equal to 2 to the power 4. So now we have same base on both sides. Same base on both sides. What we have to do? Therefore, the powers must be equal. That is 2x must be equal to the second power, which is 4. And we need to solve this now. What is x? X is simply 4. You send the 2 on the right hand side, it becomes division by 2. So x is simply 2. Right? So this is how we solve exponential equations in mathematics. Right? Let us carry on with another example. Again, solve the following equations. First part, here we have 3 to the power of x equal to 1. What is the base of the left hand side? The base is 3. And the number 1, we need to convert to base 3. Now, how can we convert 1 to base 3? Do we divide? Can we do this? No, because we can't express 1 in terms of what? Can we express 1 in terms of power 3? Can we do this division? No, we can't do this division. So we have to find a way of writing 1 in terms of base 3. How can we write 1 in terms of base 3? You recall there is a law of indices where you have learned power 0. Any number whose power is 0 gives 1. So here if we write 3 to the power of 0, this is simply 1. So 1 can be written as 3 to the power of 0. On the left hand side we have 3 to the power of x. Again, we have reached a situation in which on both sides we have the same base. right? So we have same base on both sides. If we have same base on both sides, what do? We must equate the powers. Therefore, the first power on the left hand side, which is x, must be equal to the second power on the right, which is 0. So in this case, answer is x equal to 0, right? Second part, here we have 3 power x equal to 1 over 27, right? 3 power x on the left hand side, we keep it as 3 power x. What about 1 over 27, right? Which number can we write in terms of base 3? Let us see. It appears that 27, we can write it in terms of base 3. So we keep the 1 as it is and we write 27 in terms of base 3. Let us see. 3 to the power of which number gives 27? 3 to the power of which number gives 27? So we take 27, we divide by 3. 27 divided by 3 is 9, 9 divided by 3 is 3, and 3 divided by 3 is 1. So 27 can be written as 3 to the power of 3, right? So we continue. On the left hand side we have 3 to the power of x equal to, now the fraction on the right hand side, 1 over 3 to the power of 3. How can we convert it in terms of base 3? By simply taking the reciprocal. If we take the reciprocal of the fraction, we are going to get 3 to the power of negative 3 over 1. Yes or no? Because you have learned a law of indices, the negative law. What does it tell you? If you recall, x to the power of negative m, a negative power can be converted as positive by taking the reciprocal, and the reverse also is true, right? That is 1 over x power m is equal to x power negative m. The reverse also can be written like we have just written 1 over 3 to the power of 3 as 3 to the power negative 3 over 1, right? So we continue. 3 to the power of x equal to, this is simply 3 to the power of negative 3. We have same base on both sides, so we must equate the powers. The first power of the left hand side must be equal to the second power on the right hand side, which is negative 3, right? Next part, we have 3 to the power of x minus 1 equal to 81. On the left hand side, we have 3 to the power of x minus 1. Let us convert 81 in terms of base 3. So we take 81, we divide by 3. 81 divided by 3 is 27, divide by 3, 9, divide by 3, 3, and 3 divided by 3 is 1. So 81 is 3 to the power of 4. Now we have same base on both sides, so we have to equate the two powers. Therefore, x minus 1 must be equal to 4, and x is 4, Send the negative 1 on the right, it becomes plus 1. So x is simply 5. Okay. So we proceed with this example now. So in this example we have first part 2 power x to the power 4 equal to 32. Let us simplify on the left hand side. Whenever you have two powers one after the another, like here, we have to use the power law, meaning we multiply the two powers. So it becomes 2 to the power of x times 4 is 4x, because this is what the power law tells us. You remember the power law? It tells you x to the power of m to the power of n is simply x to the power of m times n. You need to multiply these two powers like we have done here. X times 4 is simply 4x. Right? Now, since we have base 2 here on the left hand side, we need to convert 32 in terms of base 2. So 32 is 2 to the power of what? Let us see. So we take 32. We have to divide it by 2. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And 2 divided by 2 is 1. So 32 is simply 2 to the power of 5. Right? So on the left hand side we have base 2. On the right hand side we have base 2. So on both sides we have same base. What do? We equate the powers. Therefore, the first power on the left hand side must be equal to the second power on the right hand side, which is 5. So this gives x equal to 5 over 4. Right? Our answer is a fraction in this case. No problem, you can have any type of number for the answer. Whole number, fractions, it's not a problem. Let us see the second part. The second part we have 8 to the power of x times 8 to the power of 1 equal to 16. Right. If we observe the left hand side of the equation, we have base 8 for the first number and base 8 for the second number as well. And we are multiplying two numbers having the same base. So what can we do with the two powers? We need to add, because this is what the multiplication law tells us. Multiplication law, you remember? X power m times x power n is x power m plus n. So we are doing this here. 8 power x times 8 power 1, it becomes 8 power x plus 1. And this is equal to 16. Now, the base is 8 on the left hand side. Can we write down 16 in terms of base 8? Is this possible? Yes or no? Let us see whether we can write down 16 in terms of base 8. 16 we divide by 8, get 2. Can we continue to divide? No. So we can't write 16 in terms of base 8. So how are we going to proceed now? Because the trick is to convert the left hand side and the right hand side in terms of the same base, and here we can't express 16 in terms of base 8. This is not possible. So how can we solve this question? Right? We have to work with another base. Right? So this is not possible. What we do, we are going to convert the base 8 on the left hand side, we convert to base 2, and 16 also we are going to convert to base 2 as well. Right? So let us do it. Right, let me erase this to have some space. So what do we do? Converting to base 2 on both sides. Right, let us convert to base 2. Here we have 8. 8 we divide by 2 is 4. We divide by 2 is 2, and we divide by 2 is 1. Right, so on the left hand side 8 is simply 2 to the power 3. Now with 8 you have the power x plus 1. You write down x plus 1 equal to, now 16. We repeat the same steps, we divide by 2. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And 2 divided by 2 is 1. So 16 is simply 2 to the power of 4. You see, we have been able to write down both sides in terms of the same base. So now we can proceed to simplify. Right? The left hand side, we have 2 to the power of 3 to the power of x plus 1. You see, we have two powers, one after the another, like this. X to the power of m to the power of n. What do we do with the two powers? We have to multiply. So 2 to the power of 3 to the power of x plus 1 becomes 2 to the power of 3 times x plus 1. Right? We use a bracket, of course, because we are going to multiply the two powers, and this is equal to 2 to the power of 4. Right? Now, since we have same base on both sides, we have to equate the two powers. That is 3 times x plus 1. This is equal to the second power, which is 4. Right? And an equation like this, it's grade 7 level. You can easily solve by expanding the bracket. 3 times x is 3x. 3 times plus 1 is plus 3. And this is equal to 4. I carry on here. So we send the plus 3 on the right hand side. It becomes 3x equal to 4 minus 3. We have 3x is equal to 1. So x is simply 1 over 3. Again, our answer here is a fraction. Right? Let us see another example. Here we have 5 to the power of 3x over 5 to the power of x plus 1 equal to 1 over 125. On the left hand side we don't have any problem because in the numerator as well as in the denominator we have base 5. We can easily simplify, right? What about the right hand side? Can we convert 125 to base 5? Let us see. We take 125, we are dividing by 5. So this gives 25. 25 we can easily divide by 5 is 5, and 5 divided by 5 is 1. So 125 is simply 5 to the power of 3. Right? So the whole of this question will have to work it in terms of base 5. Right? We can do this. So let us start. The left hand side, 5 to the power of 3x over 5 to the power of x minus 1. When we are dividing two numbers in index form having the same base, what do we do with the two powers? We have to subtract the two powers, because from the division law, you remember from the division law, x power m divided by x power n is simply x power m minus n, that is the power of the numerator minus the power of the denominator. So here we have 5 to the power of 3x minus x plus 1, right? And now 1 over 125, 125 is simply 5 to the power of 3. We have said it before. We continue to simplify. The left hand side is simply 5 to the power of 3x. Now be very careful, we are going to remove this bracket here, right? In front of the bracket you don't have any number here, meaning you have the number 1. So we are expanding this bracket with the number 1, right? So let us expand. Negative 1 times x is negative 1x, of course, and negative 1 times positive 1 minus times plus, you already know it is minus, and 1 times 1 is 1, and this is equal to, now this is a fraction, you have negative index law. X to the power of negative m can be written as 1 over x to the power of m, right? So in this case we are here, you see 1 over 5 to the power of 3, it is in this form, right? So we need to revert back. So 1 over 5 to the power of 3 is simply 5 to the power of negative 3. Right, so we continue to simplify. The left hand side is 3x minus 1x, we have 2x minus 1, and this is equal to simply 5 to the power of negative 3. Now we have reached a step where we have the same base on both sides. What we have to do? Simply we have to equate the two powers. So 2x minus 1 must be equal to negative 3. Right? I continue here. I send the negative 1 on the right hand side, it becomes positive 1. So 2x equal to negative 2. And what is x? Negative 2 over 2, which is simply negative 1. So the final answer, x equals negative 1. Right? So let us proceed with standard form now. Well, what is standard form? Where can we use standard form? Let us see. Whenever we are dealing with small numbers, for instance decimal, for example 0.002, this is a very small number, it is very close to 0, right? Meaning it is a small number. Or sometimes we deal with large numbers, for example 2000, 20,000, 200,000, 2 million, and so on. These are very large numbers. Now whenever we have to do calculations with these type of numbers, whether it is small or large, sometimes the calculation will take much time, right? For example, if I tell you to multiply, say for example 1 2 3 4 5 6 times again 1 2 3 4 5 6, can you do this? Of course you will be able to perform this calculation, but it will take you long time to do this, right? So to alleviate this problem, we make use of what we call standard form. Standard form is simply another way of writing small numbers or very large numbers, right? It is simply a way of writing such type of numbers. Now, in standard form, we have the number which has to be written in a specific form, which is of the form a times 10 to the power of n. Every number in standard form must be like this: a times 10 to the power of n. Now what is a and what is n? Let us see. A is simply a number between 1 inclusive to 10 exclusive. What does this mean? It simply means that the number a here, it is simply a number from 1 to 10, but the number can't be 10 because here we have 10 exclusive, right? And the number can be 1. I repeat, the number a is a number between 1 inclusive to 10 exclusive. 1 inclusive means the number a, it can be 1. Yes, its value can be 1. 10 exclusive, meaning the number A must not be exactly equal to 10. It can't be 10. It can be 1. It can be any number from 1 to 10. For example, 1.1, 1.2, 1.3, 2, 3, 4, 4.1, 4.2, 9, 9.1, 9.9. It is between 1 and 10, but the number cannot be 10. Right? This is the number A. And what about n? N simply is an integer. You already know what is an integer. We have how many types of integers? We have positive integers, for instance 1, 2, 3, 4, 5, 6 and so on. We have integer 0 and we have negative integers, negative 1, negative 2, negative 3, negative 4 and so on. Right? So any number in standard form should be like this. A times 10 to the power of n. What is A? A is any number between 1 to 10 but can't be 10, and n is simply an integer. For example, here we have 1.6 times 10 to the power of 5. This number is in standard form. Why? 1.6 is between 1 and 10. It is somewhere here, 1.6. And the power 5, it is an integer. So 1.6 times 10 to the power of 5 is in standard form. Right? The second example, here we have 9.87. 9.87, it is somewhere close to 10. Yes or no? 9.87. So it is between 1 and 10. This is correct. And negative 1 is an integer. So again, we are dealing with standard form. The third example, 4.236. Let us check, is it between 1 and 10? After 1 you have 2, 3, then 4, then 5 and so on. So 4.236 is between 1 and 10. This is correct. What about the power? Is it an integer? Yes. So 4.236 times 10 to the power of 0 is in standard form. Right? So I hope this is clear. And now let us see whether you have understood standard form. If I tell you which of these numbers is in standard form, part A, is this in standard form? How do we check? Simply we check the first number. Is it between 1 and 10? Is it between 1 and 10? 1.03. It is very close to 1. This is okay. It has to be between 1 and 10. And what about the power? Is the power an integer? Yes. So definitely we have 1.3 times 10 to the power of 2. It is in standard form. Okay. What about the second one? Let us check the number first. 15. Is 15 found between 1 and 10? No, 15 is after 10. It is after 10. So it does not satisfy the definition of standard form. So 15 times 10 to the power 4 is not in standard form. Right? Though the power is an integer, this is okay. We don't have any problem with the power. But the problem is the number 15. It is not between 1 and 10. Right? Because 15 is not between 1 and 10. Right? Part C. Is this in standard form? Let us see. Let us check the number first. 10. Is it between 1 and 10? Can the number be 10? No. We have said it before. The number can be any number between 1 and 10, but it must not be 10. Here we have the number which is exactly 10, so this is not in standard form. Right? Part D. 6 times 10 to the power 1 quarter. Let us check the number first. 6. 1, 2, 3, 4, 5, 6. So it is somewhere here 6. No problem. This is okay. What about the power? Is it an integer? The power is 1 quarter, which is not an integer. So this is not in standard form. Right? What about part E? Is 0.5 between 1 and 10? No, 0.5 is before 1. Right? So this number is not between 1 and 10. So 0.5 times 10 to the power 3 is not in standard form. Right? So this is how we determine whether a given number is in standard form or not. Firstly, by checking the number, whether it is between 1 and 10, and secondly, by observing the power, whether it is an integer or not. Right? So now, how do we write a given number in standard form? This is very important. Example, we are told to write each of the following numbers in standard form. First part, we have the number 12. Right? Now, the number 12 is a whole number. Yes or no? Number 12 is what type of number? Whole number. And you know, for all whole numbers, where is the decimal point found? It is found completely at the end. Right? Now, how can we write 12 in terms of standard form? Right? What is the definition of standard form? The definition of standard form is the number has to be in the form a times 10 to the power of n, where a is a number between 1 and 10, right? So we have to convert this number 12 in terms of a number found between 1 and 12. How do we do this? By simply moving the decimal point until we reach a number between 1 and 10. Now, if we move the decimal by one decimal place, we move the decimal by one decimal place. This becomes 1.2. Yes or no? Now, 1.2, is it between 1 and 10? Of course, it is between 1 and 10. Right? When we reach a number between 1 and 10, we don't continue to move the decimal. We keep the decimal as it is. So we remain with 1.2. Then what do? We include times. Since standard form contains 10, base 10, you have to write down base 10 times 10. Now, 10 to the power of what? Right? How many places have we moved the decimal point? We have moved the decimal point by only one decimal place, yes or no? Of course, yes. So it becomes 10 to the power of 1. Now the power will be positive or negative? It will be positive. Whenever you move the decimal to the left, the power is going to be positive. If you move the decimal to the right, the power is going to be negative. Just keep this in mind. Right? So in standard form, 12 is simply 1.2 times 10 to the power of 1. Right? You can check whether it is correct or not by simply multiplying. Right? If you take 1.2 times 10, you already know this calculation. You cut the 0, you move the decimal by one decimal place, so this is simply 12. Okay? Right, this you can check whether your answer is correct or not. The second part, we have 123. Again, the decimal is completely at the end. So we move the decimal to the left until we reach a number between 1 and 10. Do we stop here? This is 12.3. Do we stop? No, 12.3 is not between 1 and 10. So we continue. 1.23. Is it between 1 and 10? Is it between 1 and 10? Of course it is between 1 and 10. So we stop here. Then we write down times 10 to the power of what? How many places have we moved the decimal? 2 places. So it becomes 10 to the power of 2. In which direction have we moved? To the left. So the power is positive. Right? So 123 in standard form is 1.23 times 10 to the power of 2. The third part, 1224. The decimal is completely at the end. We have to move the decimal to the left until we reach a number between 1 and 10. Let us see. If we stop here, we have 123.4. Is it between 1 and 10? No. So we will move by another decimal place. 12.34, is it between 1 and 10? No. So we continue to move 1 decimal 224. Is it between 1 and 10? Yes. So it is between 1 and 10. So we stop here. We write down times 10 to the power of, how many decimal places have we moved? 3 decimal places. In which direction? Left. So the power is positive 3. Right? So the answer is 1 decimal 224 times 10 to the power of 3. Right? This is pretty easy. Let us see the fourth part. Here we have 0 decimal 2. Right? Here we have a decimal number. Again, the trick is to move the decimal point until we reach a number between 1 and 10. Now, here we have 0 decimal 2. In which direction do we move the decimal so that we reach a number between 1 and 10? Do we move the decimal to the left? If we move it to the left, if we move the decimal to the left, what will happen? Will the number be found between 1 and 10? No, the number will be 0 decimal 02 if we continue to move the decimal to the left. Still, the number won't reach between 1 and 10. So in this case, we are not going to move the decimal to the left. Instead, we have to move it to the right. Let us see, if we move the decimal to the right by 1 decimal place, the number becomes 2 or simply 2.0. It's the same thing, right? Now, is 2.0 between 1 and 10? Of course, 2.0 is between 1 and 10. So we stop here, then we write down times 10 to the power of, how many decimal places have we moved? Only 1 decimal place we have moved. Now, since we have moved to the right, the power is going to be positive or negative? It has to be negative. So 0 decimal 2 in standard form is 2 times 10 power negative 1. Let us see the fifth part, 0 decimal 013. Again, we don't move the decimal to the left. Instead, we move it to the right until we reach a number between 1 and 10. Do we stop? 0 decimal 13. Do we stop here or we continue to move? We have to continue to move. If we stop here, we have reached 1.3. Do we stop here or we continue to move? We have to stop here because we have already reached a number between 1 and 10. If you continue to move, the number will become 13. Is 13 between 1 and 10? No. Right? So, then we have to write down times 10 to the power of what? How many decimal places have we moved? 2 decimal places to the right, meaning the power has to be negative. So 0 decimal 013 in standard form is simply 1 decimal 3 times 10 to the power of negative 2. Let us see the sixth part, 0.00915. Let us move the decimal to the right until we reach a number between 1 and 10. Here we have reached 0.0915. Do we stop? No, we continue to move another decimal place. We have reached 0.915. Do we stop? No, still we haven't reached a number between 1 and 10. We move by another decimal place, 9.15. Is it between 1 and 10? Of course, so we stop here. 9.15 times 10 to the power of how many decimal places have we moved? 3 decimal places. To the right, of course, the right, so negative power. So the number is between 1 and 10. This is okay. And the power is negative because we have moved the decimal to the right. Okay. So this is how we write down a given number in standard form. But always keep in mind the little rule that you must always apply, which is when you move the decimal to the left, the power is positive. When you move it to the right, the power becomes negative. Right? Now we are going to do the contrary, meaning if I give you a number in standard form, how do you write it in ordinary form? Right? We are going to do the contrary of what we have done in the previous example. Here we are told to write the given numbers in ordinary form. First part, 5.12 times 10 to the power of 1. This is very easy. 5.12 times 10 to the power of 1 is simply 10. Now this type of calculation you have covered it in primary level. You cut the 0, you move the decimal to the right by 1 decimal place. So this becomes 51 decimal 2. You see, this is quite easy. The second part, 7.86 times 10 to the power of 2. This is simply 7.86 times 10 to the power of 2 is simply 100 because it is 10 times 10. Again, you cut the 2 zeros, you move the decimal by 2 decimal places because we have 2 zeros here. Right? So the answer is 786. The third part, 9 times 10 to the power of 3 is simply 1000, and this is 9 times 1000 is 9000. The fourth part, 2.82 times. Be very careful here. Here you have negative power. What do? You convert the negative power in terms of positive. You remember the negative law of indices? You have to take the reciprocal. Right? So convert the negative power to positive power. Right? Now, 2.82 times 1 in the numerator is 2.82, and you have 10 power 1, meaning 10 in the denominator, and you already know how to do this. Here we are dividing. Whenever you are dividing, you move the decimal to the left one decimal place, so it becomes 0.282. Okay, the fifth part, we do the same thing. 4.03 times negative power becomes positive, we take the reciprocal, 1 over 10 power 2. And what is 10 power 2? 10 power 2 is simply 100, right? Before moving the decimal, let me include 1 0, then I will move the decimal by 2 decimal places because I have 2 zeros here. 1, 2, so my answer is 0.0403. Right, the last part, I have 7.1. What do? We convert the negative power in terms of positive by taking the reciprocal. This is simply 7.1 over 1000. Let me include some zeros, then I will move the decimal 1, 2, 3 decimal places. 1, 2, 3. So my answer is 0.0071. Right. So we have been able to write down a number from standard form to ordinary form. Right? So this is the end of this lesson. I hope you have understood how to solve exponential equations and how to write down a given number in standard form and vice versa. Till then, see you for the next session. Take care.